Hello, hello, hello. Here follow Organ's solutions to problem 251. Today is Thursday, March 26, 2026. Organ's solution to Walter Lewin 251's problem takes the stationary ground as the frame of reference. Fuhrson considers a moving frame of reference relative to the object at capital H. He calls this the monkey problem because I did an experiment in lecture 4 of 801 where there is a monkey at this height above the ground, and then I shoot a bullet at the monkey, and my gun is aimed exactly at the monkey. At the moment that I shoot, the monkey is confused and the monkey lets go and the monkey falls. And the remarkable thing is that now the monkey gets hit. If the monkey had done nothing, just sitting where it was, he would not have been hit. It is a dramatic demonstration. You really want to see it. Lecture 4 of 801. But let's now go back to the solutions that Organ is presenting us. Once we decompose the V0 vector in its components V0x and V0y, we can write the kinetic equations as follows. And they are in lecture 4. So I give you some time to digest that. We know that lowercase h is capital H divided by 2. He has V0x, out pops h, traditional high school physics, nothing special. He finds V0x of the bullet that I fire. He finds Y0y of the bullet that I fire. And so he finds the V0 of the bullet that I fire. So that's the correct answer for the speed of the bullet. And many of you have that. And then he calculates here the angle alpha. Tangent of alpha is V0y divided by V0x, also high school physics. And then you find that alpha is capital H, the arctangent of capital H divided by L. Fuhrson's solution is below. And he mentions that another viewer also took that approach. In the free fall frame, The object released at capital H stands perfectly still, and the projectile moves in a straight line. That's the way I solve it, by the way, in 801. If this is not clear, then take another look at 801 lecture 4, where Walter does with a free fall frame of reference. That is the frame of reference of the monkey. For a hit, the projectile must target the second object. In this frame, the distance the projectile covers in time, means the time to hit, is the square root of L squared plus H, capital H squared. On the other hand, this freely falling body falls a distance h minus h in time t. So there you get the answer to t. Therefore, the speed can be easily calculated in the free fall frame, which is done here. I suggest you read further. And what you find now is that V0 is the square root of exactly what you had before. So the dramatic thing is that I fired the gun aimed at the monkey, who is sitting high up in the tree. If the monkey had done nothing, just sit there, nothing would have happened for him or to her. But he sees the flash of the gun coming toward him, the bullet coming toward him, and then he is scared and he lets go. And that is something he should not have done, because then, as you see in the demonstration, he will be hit by the bullet. Of course, only if he has fallen a certain distance. Now, of course, I don't kill monkeys, so my monkey had a bulletproof vest. So I really urge you to watch again that classic demonstration of what is generally referred to as the falling monkey. A lot of people have this correct. How many? More than 15, which is great. I know I have already posted problem 252. So I still owe you this solution 251.